This section introduces the concept of measurand, true value, measured value, error, measurement uncertainty, and probability. Measurement is a process of experimentally obtaining the value of a quantity. The quantity that we intend to measure is called the measurand. In chemistry, the measurand is usually the content concentration of some chemical entity, molecule, element, ion, etc., in some object. The chemical entity that is intended to be determined is called the analyte. Measurands in chemistry can be, for example, lead concentration in a water sample, content of pesticide, thibenzadole, benzole, bendazole in an orange, or fat content in a bottle of milk. In the preceding example, lead, which is the element, ascorbic acid, which is the molecule, and fat, a group of different molecules, are the analytes. Water, orange, and milk are analysis subjects or samples taken from analysis subjects. In principle, the aim of a measurement is to obtain the true value of the measurand. Every effort is made to optimize the measurement procedure. In chemistry, chemical analysis procedure or analytical procedure in such a way that the measured value is as close as possible to the true value. However, our measurement result will be just an estimate of the true value, and the actual value will almost always remain unknown to us. Therefore, we cannot know exactly how near our measured value is to the true value. Our estimate always has some uncertainty associated with it. The difference between the measured value and the true value is called error. Error can have either positive or negative sign. Error can be regarded as being composed of two parts: random error and systematic error, which will be dealt with in more detail in coming lectures. Like the true value, also, the error is not known to us. Therefore, it cannot be used in practice for characterizing the quality of a measurement result, its agreement with the true value. The quality of the measurement result, its accuracy, is characterized by measurement uncertainty, or simply uncertainty, which defines an interval around the measured value, C measured, where the true value, C true, lies with some possibility. The measurement uncertainty, U, itself, has its own half-width of that interval and is always non-negative. The following scheme, similar to the one in the lecture, illustrates this, where D, which is the error, is equal to C measured minus C true. Uncertainty range is C measured minus U to C measured plus U. Yeah, that was one alarm. Scheme 1. Interrelations between the concept of true value, measured value, error, and uncertainty. Measurement uncertainty is always associated with some probability, as will be seen in the next lectures. It is usually not possible to define the uncertainty interval in such a way that the true value lies within it with 100% probability. Measurement uncertainty, as expressed here, is in some context also called the absolute measurement uncertainty. This means that the measurement uncertainty is expressed in the same units as the measurand. As will be seen in subsequent lectures, it is sometimes more useful to express measurement uncertainty as relative measurement uncertainty, which is a ratio of the absolute uncertainty, U abs, and the measured value, Y. So we have the equation U rel, which is the relative measurement uncertainty, is equal to U abs over Y. Relative uncertainty is a unitless quantity, which sometimes is also expressed as a percent. Measurement uncertainty is different from error in that it does not express a difference between two values and it does not have a sign. Therefore, it cannot be used for correcting the measurement result and cannot be regarded as an estimate of the error because the error has a sign. Instead, measurement uncertainty can be regarded as our estimate. What is the highest probable absolute difference between the measured value and the true value? That should be which is the highest probable absolute difference between the measured value and the true value. With high probability, the difference between the measured value and the true value is in fact lower than the measurement uncertainty. However, there is low probability that this difference can be higher than the measurement uncertainty. Excuse me. I'm going. Both the true value and error, random and systematic, are abstract concepts. The exact values cannot be determined. However, these concepts are nevertheless useful because their estimates can be determined and are highly useful. In fact, as said above, our measured value is an estimate of the true value. So let's unpack this second last paragraph. Measurement uncertainty in some context is called the absolute measurement uncertainty. This means that the measurement uncertainty is expressed in the same units as the measurand. As will be seen in subsequent lectures, it is sometimes more useful to express measurement uncertainty as a relative measurement uncertainty. So there's absolute measurement uncertainty and relative measurement uncertainty. Absolute measurement uncertainty has a unit. Relative measurement uncertainty does not have units. Relative measurement uncertainty is calculated by the absolute measurement uncertainty divided by y, which is the measured value. Yeah. Analytical chemists mostly use the term analytical method. In this course, we will use the term procedure instead of method, as this usage is supported by the VIM. 2. Here and in the lecture, the capital U is used to denote a generic uncertainty estimate. The symbol U is picked on purpose because expanded uncertainty, generally denoted by capital U, fits very well with the usage of uncertainty in this section. However, it is not explicitly called expanded uncertainty here, as this term will be introduced in later lectures. Okay, let's take the self-test. Now you have acquired a knowledge and an understanding of the most basic concepts related to measurement uncertainty. The following test enables you to test your understanding. Which of the following statements are true? Which of the listed differences between uncertainty and error are correct? Questions 6. Available always. Pass rate 100%. Backwards navigation forbidden. Which of the listed differences between uncertainty and error are correct? Choose. Uncertainty and error have different units. Uncertainty is surely bigger than the absolute value of the error. Error has a sign, but uncertainty does not. Uncertainty cannot be used for correcting the measured value, while error in principle could be used if we knew its direction and magnitude. Uncertainty and error have different units. Let's see, uncertainty, micrograms per liter. Error definitely has a unit because concentration of M minus concentration of C. True. That's units. That's wrong. Wrong. Uncertainty is surely bigger than the absolute value of the error. So the uncertainty range. No, that's wrong. Because it's half the uncertainty range. Uncertainty is half the uncertainty range. So if it's half the uncertainty range, then the absolute value of the error, that could be true enough. Uncertainty is bigger than the absolute value of the error. Uncertainty is bigger than the absolute value of the error. Now that could be wrong. The absolute value of the error is a probability thing, and the probability is 100%. So that's wrong. Error has a sign, but uncertainty does not. Error has a sign, uncertainty does have a sign too. So that's wrong. Uncertainty cannot be used for correcting the measured value. Let's see. The measured value is there. Uncertainty cannot be used for correcting the measured value, while error, in principle, could be used in DS. Measurement uncertainty defines an interval around the measured value within which the true value lies with some probability. True. If a measurement result has uncertainty, then it means that the measurement was not performed correctly. That's false. Measured value can be corrected by subtracting measurement uncertainty from it. Measured value can be corrected by subtracting measurement uncertainty from it. Yeah, true. Measurement uncertainty characterizes the accuracy of the measurement result. True. A measured value can be regarded as an estimate of the true value. Too bland. A measured value can be regarded as an estimate of the true value. False. A measured value can be regarded as the estimate. False. Finish. Again. %. Okay. Four to seven. Back in school, boy. And 70. Still gonna. I still give 4 to 7. you get these answers right, I had to write down the quiz answers. Oh yeah. I just do a test here and I feel wrong. I feel like a 4 to 7. So I'm doing some okay, baby. As you were. And we're gonna end it there. See you in the next session.